Welcome to LSAM Plus. This is LSAM. Today we are going to begin a course on linear algebra and matrices. And in this first lecture, we're going to start with introduction to matrices. So it's going to be a lengthy one. We'll cover everything under linear algebra. So I know you're excited to solve with me. So let's go. Let's learn matrices. So the first question will be, what is a matrix? So a matrix is simply a rectangular arrangement of elements, numbers, say complex and real numbers, rectangular arrangement. And if you have ever used a spreadsheet, you would have seen something like this. You would have seen a table like this of arrangement, let's say A, B, C, D, and so on. You would have seen something like this. So this kind of arrangement is what a matrix is. Now, like I said, a matrix is a rectangular arrangement of elements. Now, this arrangement is usually within parentheses. So you have something like this. So you have something like this. Let's say 2, 1, 4, 3. Now watch. The rectangular arrangement, watch, is in parentheses. So if you see this arrangement like this, what you are seeing is a matrix. And now because we're going to be treating plenty, so we call it matrices. So the singular is matrix 1, the plural matrices. Okay, so we just defined a matrix. Now I need to explain the concept of rows and columns so it's clear enough before we move to order. Now let me give an example. Let's say 2, 3, 4, 1. So this is obviously a matrix. It has numbers. All these are real numbers and arranged in rows and columns, rectangular and within parentheses. Now watch. This first arrangement is called row 1. So this is a row in the matrix. This second horizontal arrangement, the second one, is row 2. So first row, second row. So there are 2 rows in this matrices. In this matrix, 2 rows. So the rows are horizontal. So the rows are horizontal. Now watch. How about this arrangement? Vertical. We call them columns. So this is the first column in this matrix. This is the second column. So this matrix also has two columns, and the columns are the vertical arrangements. So column 1, column 2, vertical, up, down, or down, up. Rows, horizontal, left, right, or right, left. So row 1, row 2, column 1, column 2. Okay, so I just wanted to get that clear. So now let's look at the order of a matrix. Now, the order of a matrix is simply the number of rows by the number of columns of that matrix. So it's simple. So the order of a matrix is simply the number of rows in the matrix by the number of columns in the matrix, and this is how we present it. So the order is number of rows by written as multiplied by number of columns, number of rows by number of columns. So this is how we define the order. Now this order can also be called the size, order or size or dimension of the matrix. So the order of this matrix, or the size of this matrix, or the dimension of this matrix is the number of rows of this matrix by the number of columns of the matrix. So let's ensure that is clear enough. Let me use 1 or 2 examples. Okay, so I want to give a matrix. Let's say 3, 0, 4, 1, 2, 1, 0, 5, 5, 6, 3, 2. Okay. So this is our matrix. Now, the question to you is, what is the order of this matrix? Remember our rule. The order is what? The number of rows first by the number of columns. So how many rows has this matrix? So let's check. So this is the first row, second row, third row, fourth row. So there are 4 rows. 1, 2, 3, 4. So there are 4 rows in this matrix. So this is a 4 by how many columns? We have column 1. This is column 2, column 3. So 4 by 3. So this is a 4 by 3 matrix. Yeah, so and that's it. So the order of a matrix is just the number of rows by the number of columns. Okay, as a quick exercise, I will give you 3 matrices. You just tell me the order of these matrices, order, size, dimension. So I'll give you 3 quick ones. You just tell me that the first one is whatever it comes out to be. So I like getting feedback when I teach, so I'm very sure that everyone is following. So let's call this exercise 1. Give the order of the following matrices. So the first one is this. The second one is the third one is, let me give a fourth one. Okay, so I said I was going to give 3, but I'm making it 4. So you're going to tell me the dimension of each of these matrices. So we'll call it exercise 1 so that we can reference it. So for exercise 1, number 1 is 3 by 3 matrix. Just give the answer. So at least with this, I understand that I know that you understand what I've said so far about order of the matrix. So I would rub this. I believe you've taken it down. I'll rub it and proceed. Okay, so we'll move to notation. So how do we present matrices? The standard way of presenting these matrices. So look at notation. We've seen order, now notation. Now we use uppercase letters to represent matrices. Let's say M, N, P, S. So uppercase letters to represent, that's the name of the matrix. Now the elements in the matrix, we represent them with lowercase letters. So let's use M for example. So let's say our matrix M, watch, uppercase equal to M, 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 M. Just watch, such that our I will represent rows and our J will represent columns. Watch. So this M now is in row what? 1, comma, column 1. So we do row, comma, column. So this M is in first row. Remember, the first one is row, the second one is column. So this M is in first row, first column. This other M is in first row, second column. Remember, this is column 1, column 2. So this M is in second row, first column. And this other M is in second row, second column. So watch, represent the matrices with the matrix with uppercase letters and within lowercase. So here the first is row, second is column. So let's say you are given P as 3, 1, 2, 4, 0, 8. And I ask you, since this is P, what is P2, 1? So this 2 represents what? Row. And 1 represents column. So second row, first column. So first row, second row, first column. So the answer is 4. I hope this is clear enough. So what is P 1, 3? So P1, 3 will be what? That's the value of P in the first row, third column. So first row, column 1, column 2, column 3. So first row, third column. That will be 2. What about P2, 2? So we're looking for the element of P in the second row, second column. So first row, second row, first column, second column. So second row, second column. That would be 0. Okay, so that's how we represent matrix. So that's the general notation. So the I, J, the I is for row. Please take note, the J is for column. So do we do an exercise on this? Okay, let's move on. We'll have a lot of exercises in the end. So right now we're going to move to types of matrices. Types of matrices. Okay, I think one simple example will be fine, or like classwork will be fine. At least one will be fine. So before we move to types of matrices, let's say we have T as 3, 4, 1, 2, 0, 2, 5, 1, 3. Okay, so tell me what is T2, 2? What is T3, 1? What is T3, 3? What is T1, 2? Okay, so let's call this one exercise 2. Exercise 2. So give me the values of T2, 2, T3, 1, T3, 3, and T1, 2. So based on this T that we have, so I'll expecting your answers in the comment section. So do that quickly. Let's be sure that this is clear. You know, if we get these basics right, every other thing is just building on it. So we can't play with these basics. So I just want to be sure that you're right. And drop your answers. I'll personally answer you. I'll be there to tell you if you're right or wrong. So that will be that. So I'll rub now and proceed. Okay, so we'll move to types of matrices. So there are many types of matrices. So let's look at the types quickly. So the first one, we'll look at square matrices. So these square matrices, these are the VIPs, the VIP of matrices, because there are certain things that only square matrices can do, other matrices can't. For example, you cannot find the determinant of a matrix that is not a square matrix. So only square matrix or matrices have determinants, for example. So we give them that. Let's call them the VIPs of matrices. And what's a square matrix? It's simply a matrix where the number of rows is equal to the number of columns. So for any matrix where the number of rows is equal to the number of columns, that is a square matrix. For example, look at this. Let's say P equal to A, B, C, D. So this is a what? 2 by 2 matrix. So it's a square matrix, because the number of rows and number of columns are the same. So how about T? How about T Is it a square matrix? Yes. Because how many rows are we having here? 3 rows. 1, 2, 3. Like how many columns? 1, 2, 3. So it's a 3 by 3 matrix. So 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so on. So these are examples of square matrices. So you can find the determinant of a square matrix. We'll get to determinants soon. So if you don't know what I'm talking about, we'll get there soon. So this is a square matrix, a square matrix. So the number of rows is equal to the number of columns. So that's it. So once you have that, that matrix is a square matrix. So let's move to the next. Equal matrices. So two matrices are equal under these two conditions. One, let's say we have matrix A and another matrix B. Now, A and B are equal, one, if they have the same dimensions or order. So one, they will have the same order, and two, AI comma J. AI comma J, that's for any position of that matrix. I is 0, J is the column, right? We already explained that, equals to BI comma J. So if AI comma J is equal to BI comma J for all IJ. Now this is plenty of story. Let me break it down. Let's say we have 3, 4, 1, 2, and we don't know. Now, if you are told that A and B are equal, it means that this is A 1, 1, right? 1, 1, that's first row, first column, is 3. That means B of 1, 1 has to be 3. So for all I and J, the A of IJ must be equal to the B, that's the I and J of B. So A 1, 1 must be equal to B 1, 1. Your A 1, 2 now is what? 1, first row, second column. 1, 2 is 4, right? So our B 1, 2 has to be 4. So for all of I and J, AI comma J will be equal to BI comma J. So for the matrices to be equal. So this is 4, 1, 1, 2, 2. So what it's just telling you is that the matrices will be exactly the same. Okay, equal matrices are matrices that are exactly the same. They have the same dimensions, and for each position, the elements are the same. So that's what this second condition is saying. So let me give you a simple exercise, okay, which we'll do together on these equal matrices, and then maybe I give you one to do by yourself. Okay, so question: find x and y if x plus 2, 3, 4 y square, as if this matrix is equal to this other matrix, 5, 3, 4, 16. So the question says, find x and y if this matrix is equal to this. Okay, so obviously 3 is equal to 3. 4 is equal to 4. But now it means that x plus 2 is equal to 5. So you can say x plus 2 equal to 5. And if we solve this equation, we'll get x equal to 3 because 3 plus 2 is 5. And now y squared equal to 16. So y squared equals 16. So y equals to plus or minus 4. Right? So our x is 3 and our y is plus or minus 4. So because the matrices are equal, we know exactly what to do. Okay, so in your exam they can bring it in a more complex form, but the principle is the same. So once we get these basics right, we'll solve complex questions and we'll just be smiling because it is clear. So and that's it. So I think I'll give you an exercise 3 now on this. So on equal matrices. Just to be sure you're following. So if
life's all about balance and real love takes practice. We know accidents happen, but my love's on purpose. Reciprocate the feeling.
Okay, sorry, let me make this one y plus 2.
Everything's peachy. Everything's peachy.
Okay, so if these two matrices are equal, find x, y, and z. I mean the value. So find the value of x, y, and z. So this is a straightforward one. Even without solving, without picking your pen, I know you can get the answer. So I want to see the answer in the comment section. So I will proceed. Okay, so the next one, identity. So the identity matrix is simply a matrix whose, it's a 2 by 2 matrix whose main diagonal have elements 1 and all the other elements are 0. So it's simple. First, I said it's a square matrix and has 1 in the main diagonal. All other elements are 0. Okay, so C. And I will represent it as capital I. So I2. Remember, it's a square matrix, so a square 2 by 2 matrix will look like this. But for it to be identity, the main diagonal, you have 1 and 1. All the other elements 0, so 0, 0. So this is the identity matrix, identity 2 by 2 matrix. So remember it's square, so we can have 3 by 3 also. So identity 3 by 3 matrix will look something like this. Remember, only the main diagonal has elements 1. So 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay, so this is the identity 3 by 3 matrix, so I3, I2 for identity 2 by 2 matrix. So that's straightforward. But one thing you need to know about identity matrices, which we'll focus on later is that if you square an identity matrix I square, the answer is ti. So if you pick this matrix now, multiply it by itself, that's I multiplied by I, the answer you get is still this matrix. Please take note of this thing I'm saying. What about I cube? The answer is still I raised to power a positive n, the answer is still I. So whether it's a 2 by 2 or a 3 by 3 matrix, this is true. Okay, so that will be that for identity matrices. Now, if you have not subscribed to this channel, kindly subscribe now so you can keep getting interesting solutions, mathematical problems. Don't forget that if you don't subscribe, you might not see me again because you might not be recommended my video. So please subscribe now. So let's proceed. We move to zero or null matrix. So a zero matrix, okay, so we also call them null matrix. We represent them with capital O. So 0 0 0 0. So they behave like normal zero in your basic arithmetic. So if you add them to another matrix, the answer is that matrix because it will make no difference. So zero matrix has all the elements 0. So that one is simple and straightforward. We also call them null matrix, null, N-U-L-L. So we call them null matrices. So it can be 2 by 2, can be 3. So the dimensions doesn't matter, but as far as all the elements within that bracket, all the elements in the matrix are 0, that is a 0 or null matrix. So that's straightforward. Let's move on. So the next we'll look at row vector or row matrix. Or we'll call them row matrix. So any matrix that has just one row and 2 or more columns, watch, one row, more than one column, 2 or more columns, that is called a row vector or a row matrix. So it's simple. Look at this. Let's say A equal to 1, 3, 4. So what's the order of this matrix? This is a 1 by 3 matrix. It has just one row. It can have multiple columns. This number here, n, is 2 and above. So this where this n is greater than 2. So it can be 2, 3, 4, 5. Yeah, so this kind of matrix is called a row matrix or a row vector. Okay, the next one we'll look at column. Let's just be faster. Column vector. I know you can already predict what it will look like. One column, more than two or more rows. So if you have, let's say B as, now this is a column vector because it has one column, more than 2 rows. So this is a column vector. So n, whatever n by 1 matrix. This one is whatever, okay, 1 by whatever n, but the n is greater than 1, sorry, greater than 1. Yeah, the n is greater than 1. So 2 or more rows in this case, 2 or more columns in this case. Okay, so that's the column vector and the row vector. So let's move on to diagonal matrix. So the next one is the diagonal matrix. Okay, so that matrix that has all the other elements are 0 minus the main diagonal. So that's okay, that's to be a square matrix, yes, in which all the other elements are 0 minus the principal or the main diagonal. That is called a diagonal matrix. For example, D equal watch. So this is a diagonal matrix because all the elements in it in the main principal diagonal are non-zero, but all the other elements are 0. So look at this too. Let's say P 104. Sorry, 100 030. Sorry, 005, for example. Now, if all these elements were 1, you will call it identity matrix. So, but this one now we'll call it diagonal matrix because all the elements are not 1, but you only have elements in the principal or main diagonal. All the other elements are 0. Okay, so that's the diagonal matrix. All right, so we'll move to the next one. We are short of time. Okay. You know what? We'll end the lecture now and continue in the next video. Let's not make it too long. The video is already getting too long, so we'll continue with we have triangular matrices next. So we'll continue with that, and then after this we'll move to a lot under matrices. We'll still have dimensions, we have transpose, a lot of things to look at under this linear algebra. So stay with me and subscribe to this channel to keep getting interesting solutions to mathematical problems.